This video covers Chapter 8, Section 6 of Stat 454, Minimum Spanning Tree Algorithms. So your textbook lays out a basic step-by-step process of minimum spanning tree algorithms. These are trees that cross a whole network, assuming undirected paths. And if you go through step by step on this process and you read all of the words, basically all the minimum spanning tree algorithm does is, amongst the paths that are not currently, take all of the nodes you currently have and choose the shortest path from there going to a node not in the tree. And you can start anywhere you want. So take a second to write this image down, and I'm going to use it to create my minimum spanning tree. Let's see. So based on that image I provided, I'm going to create the minimum spanning tree. So step one was pick whichever node you want. And I think they're calling it C, is the things that are currently in the tree. I think getting started at 1 is a great idea. And then attached to 1, look at the nodes that have the shortest path going outside of 1. So going outside of 1, I see four arcs, one of length 1, one of length 2, one of length 4, and one of length 6. So I am going to choose the shortest amongst those, and that's the arc going from 1 to 2 of length 1. That's going to get added to C. So now, going off of 1 and 2, I'm going to pick the smallest arc that is not connected to either one. That is going outside of 1 and 2. So going outside of 1 and 2, I see going from left to right, arcs of length 6, 2, 4, 2, and 3. I'm going to pick the same one your textbook picks. Obviously, there are two choices, arcs of length 2. And I'm going to pick the one that goes from 2 to 5 to match your textbook on the next step. I picked an arc of length 2 because that's the smallest one going out of 1 and 2 into something outside 1 and 2. That makes C look like 1, 2, and 5. So now, going out of 1 and 2 and 5, going into something else, I have to pick the smallest one. So going out of 1 and 2 and 5, going from left to right, I see 6, 4, 4, 3, and 2. 2 is the smallest, and that's on the arc going from 5 to 3. So I've got 1, 2, 3, and 5. And now from 1, 2, 3, and 5, I need to pick the smallest one going outside of them. In other words, these will be the ones going to 4. That's arc 6, 4, and 5. Looks like that will be the one of length 4 going from 5 to 4. And notice that that one fills out this entire list. So take a look at these lengths. 1, 2, 2, and 4. So the minimum spanning tree is of length 9 and should cover all of those arcs. So I'm going to click share on the textbook to see how that compares to the minimum spanning tree I created. Let's see, they've chosen 1 to 2, 2 to 5, 5 to 3, and then 5 to 4, which matches our result. Be aware that there is an alternative version of this minimum spanning tree. It's got the same length, but different arcs. Like this. This collection of arcs has the same minimum length. This one is of length 1, this one is of length 2, this one is length 2, and this one is length 4 for a minimum spanning tree of length 9, but is a different path. It's okay to have different paths as long as the quantity is the same. There's no quick way around this algorithm. You just have to go through every single one of these steps, choosing the smallest one. But the good news is you are free to start at any node that you want. So if you had instead started at node 2, you would have the same minimum spanning tree. All right, that covers all of the information I wish to discuss about minimum spanning trees.